Hi, this is Mr. Tipton, and today we are back talking about negative exponents. We've gone over positive exponents, and we've even talked about zero as an exponent. Today we're going to look and see what happens when we go to the other side of zero as an exponent. I've set up a couple of patterns here. Let's look at this one on the left first. Here, we know that 2 to the third power is 8 because 2 times 2 times 2 is 8. 2 to the second power is 4. 2 to the first power is 2. And we know that anything to the 0 power is 1. Now if we keep going down the line, the next thing that we would want to figure out is 2 to the negative first. Look at the pattern of our answers. 8 to 4 to 2 to 1. What's happening as we go down? Well, how do you get from 8 to 4? Well, you divide by 2. How do you get from 4 to 2? You divide by 2. How do you get from 2 to 1? You divide by 2. Alright? 2 is the base, and so every time that we go down an exponent, the answer is being divided by 2. Well, we can apply that same thinking to get from 0 being the exponent to negative 1 being the exponent. We're going to divide 1 by 2. 1 divided by 2 is 1/2. Or 0.5, but we'll stick with fractions for now. If I go again, 2 to the negative second, 1/2 divided by 2 is 1/4. 2 to the negative third, 1/4 divided by 2 is 1/8. Alright? Negative exponents do not mean negative answers. What does it mean here? What do all these green numbers have in common? The 1/2, the 1/4, the 1/8, they're less than 1. They're all still positive, but they're less than 1 when the exponent is negative. Same thing over here for the tens. 10 times 10 times 10 is 1,000. 10 squared is 100, and so on. To get from 1,000 to 100, you divide by 10. You divide by the base each time. And when we get down here, 1 divided by 10 is 1/10. 1/10 divided by 10 is 1/100th. And 10 to the negative third power is 1/1000th. Okay, so again, negative exponents do not mean negative answers. It means fractions. It means less than 1, but still greater than 0. Alright, now, I don't expect us to have to make entire tables every time we want to figure out a negative exponent, so there is a quicker way to do it. That was fun, outlining my tables there. Let me show you. On the next screen here, right here, it says send negative exponents to the other side of the fraction. Here's what that means. Right now we have 6 to the negative first. Alright, we could also say that that's 6 to the negative first over 1, because anything divided by 1 is itself. So when I'm talking about sending it to the other side of the fraction, I'm talking about putting the 1 on top and the 6 to the first on the bottom. When you send it to the other side of the fraction, the exponent is not negative anymore. Okay? 6 to the negative first is the same thing as 1 over 6 to the first, which we can just say is 1/6. And if we were to make a table like we did on the first screen and do it with 6 as the base, we know that 6 to the negative first would be 1/6. Okay? 3 to the negative third is the same thing as 3 to the negative third over 1. Oops, not negative 1, just 1. And again, we're going to send the negative exponents to the other side of the fraction. So, draw a little arrow here again. 3 to the negative third is going to end up being 3 to the positive third in the denominator. 3 to the third is 27. So negative 3 to the 3 to the negative third power is the same thing as 1/27. Okay? X to the power of negative 4 is 1 over x to the 4th. Whenever you send the negative exponent to the other side of the fraction, it's not negative anymore. A couple more over here. 4 to the negative second becomes 1 over 4 to the second, positive. And of course 4 squared is 16. 2 to the negative fifth becomes 1 over 2 to the positive fifth. 2 to the fifth power is 32. Send negative exponents to the other side of the fraction. That will make them positive. A few more examples here. Okay, this one's like the ones we have been doing. 8 to the negative first becomes 1 over 8 to the first, which is just 1/8. Y to the negative seventh becomes 1 over y to the seventh. Now here's one where the negative exponent is already in the denominator. Let me get out my red arrow here. Even if it starts in the denominator, we are still going to send negative exponents to the other side of the fraction. So we're going to have x to the third over 1, which is just x to the third. See how I did that? The negative third exponent was in the denominator. Now it's in the numerator. Always send negative exponents to the other side of the fraction. Here we have 4 times c to the negative third. Notice the difference between 4c to the negative third and 3x to the negative first. The 3x, that whole thing was to the negative first. It was in the parentheses. That's why I sent the 3 and the x to the denominator. But 4 times c to the negative third, remember exponents happen before multiplying in the order of operations, so it's really only this c that's to the negative third. So the 4 is actually going to stay where it is because the 4 does not have a negative exponent with it. But the c to the negative third needs to go to the other side. Okay? Same deal here. The negative 2 exponent is not with the negative 6. It's with the q. So negative 6 is going to stay on top, but q to the negative second is going to get sent to the other side of the fraction and become positive 2. Okay? That's pretty much it. Negative exponents, we don't like them. Send them to the other side of the fraction and make them positive. That's going to make future things a whole lot easier to deal with. If you have questions or what ifs, jot them down on the sides of your paper and we'll talk about them soon. See you then.